Section 7.4 is more on quadratic equations, and there are three objectives. Number one, to determine the nature and the solutions of a quadratic equation. Then part B is about writing a quadratic equation having two given numbers as solutions, and then solving equations that are quadratic in form. So I will explain what that means. And so the first topic will that be of the discriminant. And so when we solve a quadratic equation in standard form, and then we have the solutions, the quadratic equation being, ax squared plus bx plus c equals 0. So we know the two solutions are x sub 1 equals minus b plus the square root of b squared minus 4ac divided by 2a. And the other solution is minus b minus the square root of b squared minus 4ac divided by 2a. So the expression, the radicand, b squared minus 4ac, that is called the discriminant. So b squared minus 4ac. So here's a summary of what that means. If the discriminant is equal to 0, then there's only one solution. Because if that's 0, then we simply have x sub 1 is minus b divided by 2a, and that's the only solution there is, because that expression is 0. If b squared minus 4ac is equal to 0. Now, if b squared minus 4ac is positive, then we have two different real solutions. And when the discriminant is negative, then we have two different non-real complex number solutions. They're, of course, complex conjugates. So we had seen this before. So now we're just going to summarize everything from the standpoint of the discriminant, b squared minus 4ac. So let's do some exercises about determining the nature of the solutions without solving the equations. So we have a equals 1 in this example, a equals 1, and b is equal to 5, and c is equal to negative 3. So a squared, or b squared minus 4ac, b squared minus 4ac is equal to 5 squared minus 4 times a times 1 times c, or negative 3. That's equal to 25 plus 12, or 37. So in other words, that's the second case. It's positive. So we have two real number solutions. Two real number solutions. In other words, just from looking at the discriminant, we can determine what kind of solutions we're going to have. In example 2, again, we identify a, b, and c. So here we have a equal to 9, b equal to minus 6, and c equal to 1. So then b squared minus 4ac would be minus 6 squared minus 6 squared minus 4 times 9 times c would be 1, would be 36, and 9 times 4 is 36 with a minus, so minus 36. That's equal to 0. And so that means we have one real solution. So the discriminant is equal to 0. We have one real, one solution. We don't need to say real, but one solution. because as we know, if they're complex, they show up in conjugates. So one solution. In example number 3, we have 3x squared minus 2x plus 1 equals 0. So a equals 3, the coefficient of x squared. B is equal to negative 2. And c is equal to 1. So then b squared would be minus 2 squared minus 4 times a minus 4 times 3 times c. So that's equal to minus 12, and 4 would be minus 8. So the discriminant is negative. So therefore there are two non-real solutions, and again they're complex conjugates. Complex conjugates, to be specific. The second objective was to write equations from solutions. So here the question is, find the quadratic equations having the following solutions, 7 and minus 2. So what that means is that x equals 7 and x equals negative 2, or x minus 7 equals 0, and here x plus 2 equals 0. From the zero product principle, we know that the product of the two factors, x minus 7 and x plus 2, has to equal 0. Otherwise, these numbers couldn't be solutions. So then we use the multiplying two binomials. So the x times x is x squared, and 2x minus 7x is minus 5x. Minus 14 equals 0. For number 5, we have x equals negative 4 and x equals 5/3. So that means x plus 4 equals 0, and this would be the same as 3x equals 5, or 3x minus 5 equals 0. So from a zero product principle, we multiply these two factors, x plus 4 times 3x minus 5 equals 0, and multiplying these two binomials gives us 3x squared plus 7x minus 20 equals 0. So that's the quadratic equation corresponding to these two solutions. So 3x squared plus 7x minus 20 equals 0. And for number 6, we have x equals 5i and x equals minus 5i. So in other words, x minus 5i equals 0, and x plus 5i equals 0. So then from a zero product principle, we can write this as x minus 5i times x plus 5i equals 0. And multiplying these two expressions, we get x squared minus 25i squared equals 0. Now remembering that I equals the square root of minus 1, so that means that I squared is equal to negative 1. So then we have x squared minus 25 times minus 1 or x squared plus 25 equals 0. So x squared plus 25 equals 0. As number 7, we have x equals minus 2 times the square root of 2. And for the other solution, x, we have x equal to the square root of 2. So that means we have x plus 2 times the square root of 2 equals 0. And x minus the square root of 2 equals 0. Multiplying these two factors gives us x plus 2 times the square root of 2 times x minus the square root of 2 equals 0. So that's equal to x squared, and then minus x times the square root of 2 plus 2x times the square root of 2 is x times the square root of 2. And 2 times the square root of 2 times square root of 2, square root of 2 times square root of 2 is 2, and 2 times 2 is 4. So that is the answer to this next exercise here. So x squared plus x times the square root of 2 minus 4 equals 0. And then for number 8, we have x equals minus 7i, and we have x equals 7i. So then that gives us x plus 7i equals 0, and x minus 7i equals 0. Multiplying these two expressions, we get x plus 7i times x minus 7i equals 0 from the zero product principle. So it gives us x squared minus 49i squared equals 0. And since I squared is minus 1, we get x squared plus 49 equals x squared plus 49 equals 0. So remembering I squared equals negative 1. So x squared plus 49 equals 0 for number 8. Part C is about equations that are quadratic in form. And to begin with, we're going to look at an example. Solve x to the 4th minus 10x squared plus 9 equals 0. Well, we don't have an x squared, an x and an x squared, but we see that this expression and this expression, they're related. We square x squared, we get x to the 4th. So what we do in a case like this, we let u equal x squared, and then u squared would be x to the 4th. So we do substitution basically. So then x to the 4th minus 10x squared plus 9 equals 0 turns into x to the 4th was equal to u squared. So u squared minus 10x, and x squared is u, so minus 10u plus 9 equals 0. Now this looks very familiar, and so we can solve this by factoring. So that factors into u minus 1 times u minus 9 equals 0. We set each factor equal to 0. So u minus 1 equals 0, or u minus 9 equals 0. So that means u equals 1, or u equals 9. Now remember, u was equal to x squared. So that means x squared equals 1, or x squared equals 9. So we take the square root on both sides, and that gives us x equals plus or minus 1. And on the other, for the other solution, x equals plus or minus 3. So all four numbers check. So the four solutions are minus 1 and 1, and minus 3 and plus 3, or just 3. So that's how we can solve equations that are quadratic in form by using substitution. Let's look at the following exercise. X plus 3 times square root of x minus 10 equals 0. So here we can make the substitution u equals square root of x, and then u squared equals x. So therefore, this equation that becomes u squared plus 3u minus 10 equals 0. And we can easily factor this into u plus 5 times u minus 2 equals 0. Setting each factor equal to 0, u plus 5 equals 0, or u minus 2 equals 0, gives us on one hand u equals negative 5, and this is u equals 2. Now remember what u is. U is equal to the square root of x. So in other words, now we substitute this back into this expression. So for this solution, we have 2 equals the square root of x. So then x, when we square both sides, x is equal to 4. And when we substitute that into the original equation, 4 plus 3 times the square root of 2 is 6. So 4 plus 6 minus 10 is 0. So that checks. However, when we use u equals minus 5, we would get minus 5 equals, or rather, minus 5 equals the square root of x, but the square root of x is not negative. So this solution is not a real solution that we can apply here. So the only solution then to this equation and form is x equals 4. For the next exercise, we can use a similar substitution. We can let u equal x to the minus 1, and then u squared equals u to the x to the minus second power. So then we get u squared plus u minus 6 equals 0, and we can factor that into u plus 3 times u minus 2 equals 0. Setting each factor equal to 0 gives us u plus 3 equals 0, or u minus 2 equals 0. So in other words, u equals negative 3, or u equals 2. Now, u is equal to x to the minus 1, so that's 1 over x. So 1 over x equals minus 3. So then x equals minus 1/3. And for the other solution, again, 1 divided by x equals 2. So that means x equals 1/2. So these are the two solutions to this equation. To find the x-intercepts of f of x equals x squared minus x quantity squared minus 14 x squared minus x plus 24, we set that function equal to 0. And so we can use substitution here also. We let u equal x squared minus x, and then u squared is equal to x squared minus x parentheses squared. So this then gives us u squared minus 14u plus 24 equals 0. We can factor this into u minus 2 u minus 2 times u minus 12 equals 0. Setting each factor equal to 0 gives us u minus 2 equals 0, or u equals 2, or u minus 12 equals 0, or u equals 12. Now remember what the u is. U is equal to x squared minus x. So then we have the following. We have x squared minus x equals, the first solution equals 2, or x squared minus x minus 2 equals 0. We can factor this as x minus 2 times x plus 1 equals 0. And so we have two solutions here, x minus 2 equals 0, or x plus 1 equals 0, which means x equals 2, or x equals minus 1. And then for the second solution, u equals 12, again, we use this form here. We have x squared minus x equals 12, using the second solution here in connection with this definition of u. So that means x squared minus x minus 12 equals 0, and we can factor this as x minus 4 times x plus 3 equals 0, and so we have x minus 4 equals 0, or x plus 3 equals 0. In other words, we have x equals 4, or x equals negative 3. So here are four solutions for x. And what that means, since we're supposed to find the x-intercepts of this function, it means we have the intercepts negative 3, comma 0. That's one of the intercepts. Then we have negative 1, comma 0. And then we have 2, comma 0. And we have 4, comma 0. So these are the intercepts for the given function. This concludes section 7.4.